Okay, we are moving on to 5.2. Last week, or previous section, we had worked on solving systems of linear equations by graphing. And now we're going to look at one of our other two methods we're going to do in this chapter, the next one being substitution. So we always want to keep this in mind with doing systems. What does it mean to solve a system of linear equations? And hopefully you remember back to graphing. When we graphed in an xy coordinate plane two linear equations, doesn't matter how those lines go, but what we were doing is looking for that intersection. And remember, when you're talking about a coordinate plane and an intersection, we're talking about ordered pairs. What does it mean to solve a system of linear equations? I'm just going to say graphically. So on a graph, when I graph those two, graphically, it is the intersection. It's where those lines cross. And remember, in order to be a solution to a linear equation, a solution is an ordered pair that lies on the line. And the only way that a point can lie on two lines at the same time is if it's where those lines cross. So graphically, it's the intersection of the lines. And I want us to remember too, that your answer, or answers, we're just going to say answers, your x and your y, are ordered pairs. I would look at where these lines cross. I would get the ordered pair. I could plug that x and my y back into my original equations and certainly test to make sure that they were solutions. This way, substitution, a lot of you will like this, and the process is not hard. What happens with these is there is a lot of room for just little mistakes, little arithmetic mistakes, adding and subtracting negative numbers. There's going to be some distribution in there. We're going to be back to solving two-step equations, so there's mistakes to be had. Here's a step-by-step on how to do it. The first thing you want to do is get y by its x or y by itself, whichever's easier. You want to solve for one of the variables. So if I look at this example right here, I want to see, is there an x or a y by itself? Meaning, is x solved for something by itself, or is y by itself? And I can see right now that y is by itself, and that's going to be important. Because when I have one of the variables, or even both, that are by themselves, substitution is a very viable option to help solve this system. What you will do is if I have two and I'm trying to find out where they're equal, because this is what y equals, I can take this whole expression right here, this 2x minus 4, and substitute it in for the y right here. Because remember, this is what the y equals, and since I'm solving these, so the way I like to do it, once I've said, hey man, this y is by itself, wouldn't it be nice if I took this expression and put it right here for y? Meaning this whole thing is going to be that 2x minus 4. Now I got to be careful here, because there is a 2 out front, and even more specifically, a negative 2. And remember, this is negative 2 times y. So I'm going to have negative 2 times y, and remember, y is this whole thing. So I'm going to have to do some distribution down here for sure, but we'll get to that. First thing I like to do is put some parentheses around there to remind myself that this entire expression needs to be substituted in there for y. Step one here was to make sure this y was by itself, an x or a y. Step two is right here. I take that expression and substitute it in. You then need to rewrite your equation. So this becomes 7x, I leave it, minus 2, and remember this is 2 times y. So it's times y, which I know y, I'm now going to use this expression of 2x subtract 4, and that whole thing should equal 5. And here's where the mistakes can happen. We got to take care to plugging these in and making the right decisions mathematically. If you have a number out front of the variable that you're substituting for, you ought to be thinking every time you're going to have some sort of distribution. In this equation now here, I don't have a y anymore. I have it in terms of x, which means I'm going to be able to solve for this x. I went from 2 variables down to 1 by simply substituting that in. And I'm allowed to do that because this is a system and we want to know when they're equal. 7x would stay. I need to distribute -2. And I need to do that to both terms. Take care in doing this. -2 times a positive. Well, that's going to be a negative, and I have 2 times 2x, which would give me a -4x. -2 times a -4, +8, and that's going to equal 5. And again, take care when you're distributing. If I made a mistake here or here, it's not going to come out. I'm not going to get the right intersection. Just like if I graph the lines wrong, you ain't going to get the right intersection. If you figured your slope wrong or your y-intercept when we were graphing these last week, same thing goes here. If we make a mistake, we're not going to get the correct solution. Then we'll have to backtrack. You're going to have some like terms to combine. Always going to have some like terms. And I see it's 7x and a -4x. So 7x minus 4x is 3x plus 8 is equal to 5. I now have to solve for x. Two-stepper. Back to two-step equations. Haven't done these in a few weeks. I got to get this x by itself. And then remember, x is being multiplied by 3 and added by 8. To solve the equations, we need to reverse that. I would have to subtract 8 and divide by 3. First step, subtract 8. What you do to one side, you must do to the other. The 3x would come down. That goes away. 5 minus 8, -3. Divide both sides by 3. This step right there. X then would equal negative divided by a positive is a negative. Anything divided by itself is 1. And I have one piece of the puzzle. That whole thing right there, that substitution, that was your step 2. You substitute it in, and then you solve for the other variable. I took y and plugged it in, which means I was going to solve for x. Remember though, answers are ordered pairs. You have an x, now I need to find out a y. I'm on to step 3. We want to substitute the value from step 2, -1, into either one of these original equations. It doesn't matter which one I use. Now when I look at this, if I'm looking to solve for y, I like this first equation because y is already by itself. So I'm going to take this -1 now, and it's going to go back in up here, right where that x is. So this equation, and that's your step 3 when you substitute it back in. So this equation over here becomes y is equal to 2 times my x, which is -1, subtract 4. Y then would equal -2 minus 4. Y is equal to -6. You have an x, you have a y. I write these as an ordered pair because a solution to a system of linear equations is an ordered pair. And I get -1, -6. And you could certainly plug this into both equations and check it. I already plugged it into here. If I plugged it into the second one, -7, because -1 times 7, that'd be a -7. -2 times -6 would be a +12. So you have a -7 plus 12. That indeed equals 5. That checks in both of them too. I can always check them. On the next one, we'll go through the same steps. Look to see, is there a variable by itself? Well, both of these are. Now I've got the decision to make. I could take this y and put it in right here, or I could take this 2x plus 3 and put it in right here for y. What's easier? I don't know. To me, if I have this as 5x is equal to 2x plus 3, I can see if I just move my 2x over, I'm ready to go. If I take this 2x plus 3 over here, I can do it the exact same way and get the same answer. Doesn't matter which way I go. I'm going to take this 5x right here and plug it in. That's my step 1 or step 2. I identified both of them I could have substituted in. Now I'm going to take one of them and substitute it in. 5x then is equal to 2x plus 3. I got to get my x's on one side to solve for it. I certainly don't want to move my 5x over because now I've got variables and integer on both sides. This is going to be equal to 0. If I move this 3 over, I ain't no close to getting x by itself. I would still have to move my 5x or my 2. Easiest way to solve this is to simply subtract 2x from both sides. 3x, that would go away, is equal to 3. 3 times what number is 3? Well, I could divide both sides by 3. X then would equal 1. There's one piece of the puzzle. To find out what y is, I'm just going to put it in right there. Y is equal to 5 times 1. Y is equal to 5. You have an ordered pair now. Write it as such. I have the ordered pair 1, 5. And you could surely plug these back into both equations and check it. If this is 5, 5 would have to equal 2 times 1 plus 3. Well, what's 2 plus 3? It's 5. I already checked this one. 5 would equal 5 times 1. It checks, and I'm good. Once we have the process down, it's not bad. Then it's just the details. Let's look at this next example. And again, we just need to practice. Do these over and over and over. Do I have a variable by itself? I do. I have this y by itself, which means I am going to take this expression and substitute it in right there for y. This then becomes 4x plus 2 times. I got to times it by y. Y is now 1/2 x minus 5. I substitute that in, hence substitution. That equals 0. Whenever you have that number out front, yes, you are going to have to distribute or multiply. So I distribute 4x plus, now this is a 2. 2 times 1/2, well, half of 2 is just 1, so that's just going to be an x. 2 times -5, -10 is equal to 0. You are going to have like terms to combine. You have a 4x and a 1x. 4 plus 1 is 5x minus 10 is equal to 0. Hopefully you can tell what this answer is right now. This would have to be 10 minus 10. What would make that 10? Well, if x was 2. I'm going to finish this though by adding 10 to both sides. 5x would come down. This is 0. 5x is equal to 10, and it's looking good from what we thought it would be. 10 divided by 5, x is equal to 2. You have one piece of the puzzle. I need to find out what y is, and since y is already by itself right here, it would be nice and simple if I just took this 2 now for x and plugged it in right there. So this is going to become over here, right here, this is going to become y is equal to 1/2 times x, which is now 2, subtract 5. Y is equal to half of 2, or half times 2 is 1, minus 5. Y is equal to -4. You have an x, you have a y. I write them as an ordered pair. The solution to this system of linear equations is the ordered pair 2, -4. Keeping in mind that just because we didn't graph them, if I graphed both of those lines, they would intersect at the ordered pair 2, -4. And again, the process isn't that difficult, but there are mistakes all over that can be made in distribution, adding and subtracting negative numbers, and we just got to take our time, use our calculators. Next one. The only thing different on this one is now if I look, well, y isn't by itself, but x certainly is. That's okay. I'm going to keep doing it the easy way. If x is already solved, I now take this, what this x equals, but I don't plug it in for y. I plug it in for x. So this becomes 2 times x, which x is this, 5y plus 3, plus 4y is equal to -1. And the only thing that's changing into this one is now I'm going to solve for my y first, but that's okay because once I have my y, I'll plug it in right back up here, multiply it by 5, add 3, and I'll have my x. Distribute. Distribute means multiply. 2 times 5. 10. 10y, 2 times 3, plus 6, plus 4y is equal to -1. You're going to have like terms to combine. We're always going to have some like terms because we're combining some variables there. 10 plus 4, 10y plus 4y, 14y plus 6 is equal to -1. Two-step equation. Y is being multiplied by 14 and added by 6. I need to reverse this by subtracting 6 and then divide everything by 14. I need to get this y by itself, so this 6 has to go over. It's a positive 6. I use inverse operations when going back and forth across the equal sign. 14y would stay. That's 0. -1 subtract 6. -7. Divide by 14. And I get y is equal to -7/14. Yes, you may get a fraction here or there. 7/14, hopefully you realize, reduces to a -1/2. -1/2. Y is equal to a -1/2. There's one piece of the puzzle. I will take that y and I'm going to plug that in right there so I can find my x. I could certainly plug it in this one, or I could plug it in, I could plug in y right here and solve for x. If I plug it in right here, x would equal 5 times a -1/2 plus 3. 5 times a negative 1/2, negative 5/2, because remember 5 times negative 1/2, numerator times numerator, denominator times denominator when multiplying fractions, plus 3. Negative 5/2 in a decimal is negative 2.5 plus 3. This is going to come nice because negative 2.5 plus 3 is just going to give me 1/2. Or you certainly could use your calculator to do that. So x is equal to 0.5. I'm going to put it into a fraction because this isn't a fraction. I now have my ordered pair with my x of 1/2 and my y of negative 1/2. And I got it. And I could have certainly taken this negative 1/2 and plugged it into this equation to find out what x is. And I'm going to do that over here. 2x plus 4 times negative 1/2 is equal to negative 1. 2x, half of 4 is 2, positive times a negative. 4 times negative 1/2 is negative 2, is equal to negative 1. I would add 2 to both sides. 2x then is equal to 1. I would divide by 2, x is equal to 1/2. I still get the exact same answer as I got over here. What's easier? To me, it's this one because I don't have any fractions. But it certainly doesn't matter. Whichever one you plug into, see it out. When I look at this, I see that if this y is 1/2, to me, my eyes went right here. Because I know multiplying by 1/2 is like dividing by 2, and 4 is divisible by 2. I know I wasn't going to have fractions doing it this way. This one I kind of knew that I would because I've got an odd number times a fraction of 1/2, which means I'm dividing by 2. 5 ain't divisible by 2. I know I'm going to get a fraction there. But I can certainly handle it, and I did, and got the exact same. Last example. This one is equal to negative 1. Forgot to put that on there. I'm going to go through my steps again. I look at this. This time, I do not see a variable that's solved by itself. But I could easily solve for y here because the coefficient is 1. I could move this 3x over, which would be y is equal to negative 3x plus 1, or up here, I can just add x, and I'll have y by itself. Or I could subtract y, but then I've got a negative x. I'm always looking for the easier, softer way. And the more of these that you do, the more you'll pick up on the easier way to do it. To me, to get this x over here would be the easiest because then I have y is equal to a positive x plus 3. I'm going to add x plus x. That means y is equal to x plus 3. When there isn't a variable solved by itself, pick a variable and solve for it. And again, I'm always going to pick the variable that has a coefficient of 1 in front of it because then I know I just have to move it and I've got it by itself. In this case, if I had chosen to solve for x, I would have had subtracted y and divide everything by 3. And then you're going to have fractions. Just start looking, what is the easiest way? I'm going to tell you this is because my x is positive now, my y is positive now, and I've got y is equal to x plus 3. I now take that x plus 3 and I substitute it into the other equation. That whole thing would go right there. How nice is that? Because now this equation becomes 3x plus x plus 3. And I don't have to multiply it or distribute because that's a 1 out front. And if I distribute a 1, I know I just get what I started with. That whole thing is going to equal negative 1. You will have like terms to combine. A 3x plus 1x is 4x plus 3 is equal to negative 1. Two-step equation. X is being multiplied by 4, added by 3. I need to reverse this by subtracting 3 first. That goes away. Negative 1 subtract 3, negative 4. I would divide by 4. X would equal a negative 1. I will take that negative 1 and I'll plug it into either equation. I don't know. I'm just going to choose this one. Back to my originals. It's closer. 3 times negative 1 plus y would equal negative 1. 3 times negative 1 is negative 3 plus y is equal to negative 1. It's a negative 3. Oops, whoops, why did I write 4? It's a negative 3, so I would add 3 to both sides. That goes away. Y is equal to negative 1 plus 3, which is 2. I now have the two things I need to write my answer as an ordered pair, negative 1, 2. And I could certainly check this. Negative 3 plus 2 is indeed negative 1. Negative negative 1, positive 1 plus 2 is 3. It checks and I box it in. Again, these take practice and we're certainly going to practice them.